Hey guys, today we're going to be talking about question number 15, three-sum. So this is similar to, or we'll be using concepts that we've come across in two-sum or two-sum sorted. So go ahead and try and watch those first before you attempt this question. Let's look at the example right here. So the question is just asking us, given this input, right, what are the three values that will sum to 0? So from Leetcode, you can see, okay, nums I plus j plus k equals 0. What are the three values that will sum to 0? And there might be multiple sets. Similar, for example, here, there's -1, -1, 2, -1, 0, 1. There can't be duplicate sets, though. We can't use 1, 1, 2, or 2, -1, -1 multiple times. So each set has to be unique. So given that list, how do we find the sets that sum to 0? So let's take a look at the naive way first, and I'm going to try something different today. I won't live code everything out. I'll have the code already pasted, and we'll just walk through it. And let me know how you guys think that goes. So this is our example right here, right? We have -1, 0, 1, 2, -1, -4. This is our list represented in the chart and our index values on the bottom. The naive solution would be to use a triple loop, right? So we start over here, and then we say, okay, let's call that A. Then this is our outside loop. We have our A. That doesn't look good. A. And then our second loop is going to be B, right? So let's do that. So it's going to be B here, and then that third loop is going to be C. So what happens is that we have -1, we have 0, and we have 1. Okay, so does that equal 0? This equals 0, so we'll push that solution into a solutions array. Then we're looping C, right? We're looping C, we're looping C, we're looping C, and then we say, okay, let's move our B here, and then let's start our C here, and then we'll loop C, and it keeps going, and it keeps going, and then so on. We have our B, and then our C here, and then it goes on and on and on up until we finished everything in that loop. Then we go to the next loop here, and we continue that whole process of our triple loop. That would be the super naive solution. Now, the way we should be doing it is actually, so right now what we have is an unsorted array. If we want to borrow concepts from two-sum sorted, the best thing to do here is to first sort it. So let's scroll down here. This is that sorted array that we have. So if we say, okay, let's just mark down this value first, right, as A. Given that we have A selected, right, we have, what we need is a value of A plus B. All right. That is a little bit slow to draw with, plus C. Okay, so given we have A first, which is -4, what we should be doing is, because it's sorted, then we can say, okay, let's have our B and our C all the way at the other end. And instead of B and C, let's call this left and right pointers now, right? We have our left pointer and we have our right pointer. And now this question actually, this part now is two-sum. So we have -4, and we have -1, and we have 2. Does this value sum to 0? Well, from what we can see, -4 plus -3 is going to -1. It is less than 0. So that value that we get, this is less than 0. It's too small. How do we increase this total value? Well, just by moving the left pointer, right, that goes out, we shift our left pointer here. And then you'll see that, okay, actually, it's still going to be less than 0 because these two values are the same. So then we shift our left pointer here. All right, okay, what's the result from here? Okay, it's still going to be less than 0 because -4, right, plus 0 plus 2, it's going to give us -2, less than 0. We move it here, and what we find is that, okay, at this junction right here, at this point in time, we have not found a solution yet. All right, so let's go back, and now let's shift our A value. Let's go here. So now we have a loop here, we look at this portion, and then we're doing our left and our right pointers again. All right, so -1 plus -1 plus 2, that is a solution that works. Okay, so now that we've found a solution that works, which is this, and this, what do? Well, what we have to continue to actually shift the left pointer. So we'll shift the left pointer here, and R stays here, the right pointer stays there. Do we find a solution? We have -1, 0, 2, and that is a -1, 0, 2, that is not a solution, right? So we shift our left pointer, and well, actually, hold on. Let's go back, -1, 0, 2. What does that give us? -1, our left pointer was here, our right pointer was here. -1, 0, 2, that is actually greater than 0, right? We have -1 plus 2, which gives us 1. That's greater than 0. So what we need to do is shift our right pointer down. We're decrementing that value, right? So now we got -1, 0, 1, and look, we found another solution. And finally, what do? When we find another solution, we can increment our left pointer by 1. And once it gets up to here, once L and R are equal, that is when we stop our while loop. So there's going to be a for loop and a while loop. That for loop is incrementing the first value, the A, B, C, the first value of our 3-sum. That while loop is going to be shifting the left and right pointers back and forth. All right, so I kind of explained the concept here is that using a for loop and a while loop, the while loop is going to be moving left and right. So let's look at that code that I said I copy and pasted right here. Hopefully we can get it to a size where it is legible. So the first thing that we're doing here, we are sorting that array, right? We get it into an increasing order. I have my result array, which is what we're going to push the values for. Now look, right here, this first for loop, for let I equals 0, I is less than nums, I 1 plus 1. That is going to be this A right here, right? This is going to be what we do to shift that first value up and down, up and down. And remember, we don't want any duplicates. So what happens if our A is right here, right? We know that its previous value is -1. So what we're going to have to do is if we land on a value that is same as its previous value, we need to continue this loop. We need to move that A over here, right? So this is that portion where we are skipping any duplicates, right? So if we're at a value that's greater than I, right, that second value or that first index in the array, and if its current value is the same as its previous value, let's skip it. Let's continue. All right, so that's what we're doing here. And once we've found a unique value, we say, okay, let left value as that I plus 1, that value right next to the first value. So if A was here, or if I, let's use I now. If I was here, I plus 1 is here, R is the end of the list. And we do that right here. Let L equals I plus 1, let R equals the end of that list. And then we have our for loop with every I loop iteration. And as long as left index is less than right index, we have our total sum, our 3-sum, right? Nums I plus nums L plus R. Now, if that sum is greater than 0, we decrement the right pointer. If that sum is less than 0, we increment that right pointer. Now, if we find that value that we need, we just push that result in, and then we continue to increment that left pointer. Now, we do this part while nums L is equal to L minus 1, and as long as L is less than R, we're incrementing. And that is also to prevent any duplicate values, right? So we had an example earlier where, okay, let's say for example, right here, right? Our target value was 0, but let's say our target value was -4 minus 1, that's -5. Let's say our target value is 3, okay? 3 is our target value. We are at this point right here, okay? 3 is our target value. If sum is equal to 3. We found our target, -4. Then we increment L. Now if we increment L, let's change the color. Let's cross that out because we're incrementing L, so L is right here, right? -4, -1, -2. That is a duplicate set. So we don't want a duplicate set, right? So we have to do this right here. So while L is equal to its previous value and it is less than R, let's increment L again until we get to a point where L is no longer equal to its previous values. All right, so this is what this while loop is here for, and we're incrementing it. That is basically the code right here for this solution. So let's go back and try to implement that. So the first step that we wanted to do was we wanted to sort that array in an ascending a descending order from small to large, right? Now that we've sorted it, let's have our result, which is what we're going to push our result into. Let's see if I can zoom there. It might be easier for you to see. Now we have our result. Now again, we have our for loop, which is that outer first value that we want. Let I equal to 0, as long as I is less than that nums.length, and we're incrementing always by 1, right? Now remember, what happens if I is greater than 0? So we've already gone through our first iteration of the loop, right? We are here, I, or let's say we're here. What if that previous value is the same? We need to increment I up into the point where it's not the same, right? So if I is greater than 0 and nums I is equal to its previous value, what do? We need to continue. And that's it for the checking if we have a duplicate value of that first value, of the first value of the 3 sum. Now we can say, okay, let L, our left pointer, is equal to I, or I plus 1, right next to it, right? And let R equals nums.length minus 1. These are the index values. Let's zoom out now. So we have our left pointer and we have our right pointer. Now remember we said while the left pointer is less than the right pointer, right? Let's calculate that sum. That sum is just nums I plus nums L plus nums R, left plus right here. So that is our sum. And if that sum is greater than 0, right, the only way to decrease our sum value from our target is to decrement that R, shift that right pointer. Now, if that sum is less than 0, we need to increase our total sum. And therefore, we are going to increment our left pointer. Right now, if that sum is equal to 0, we found our target. That's great. Let's push that into our results, right? Nums I, nums L, nums R. After we do that, we want to shift our left pointer. But if we shift to a left pointer that is equal to the previous value, we need to continue shifting it, right? So while that nums L is equal to the previous value, and as long as the left pointer is less than that right pointer, everything is still valid, we're going to keep incrementing. And at the end of the day, we're going to return our results. Let's zoom out. See the code here. Let's just submit that. There is an error. What do we have here? Expected a return type of number. So res.push, nums I, L, R. Right, we have a res. Are we returning res? Yes, we are. While left is equal to left plus 1, and as long as that, res.push. What is that error that we have here? Expected. Well, let's go ahead and just console log that. It doesn't seem like we're getting to 0 actually. Nums I plus nums L plus nums R, right? Nums is that value. While the sum, continue. I don't see what's wrong. Let's console log that log. All right, we got a 0. If the sum is equal to the 0, oh, I'm not actually pushing an array. My bad. We're pushing an array right here. We're submitting it. Loading. And you know what's probably taking a long time? It's that console logging of the sum. Let's get rid of those. See that? Time limit exceeded. Where else do we have? Let's submit. There we go. All right, beat 73%. So it's actually not bad. I had a bug where I did not push an array. So don't do that. Thanks, guys.